Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. The next component on the knee build for this miniature drill press is the crank handle here that will raise and lower the entire assembly once it's all assembled together. There are two of these handles. There's one that's bent 3 times, and the one up on top, the one that you would grab if you were drilling a hole. This is the one that activates the drilling mechanism itself, brings the quill down. Well, that would be the second one, and that looks like it's only bent twice. I am not going to put the square hole in the center prior to bending because I just feel that once you bend it right here so close to a thin wall, that it's going to distort that pocket and it's going to look unsightly. So since the square end is the thickest part of the entire crank, I'll do that after the fact. This part starts off on the lathe, gets a little bit of ornate turning on the outside, and then 3 creative bends, and then broached. Starts off at 3/16 square brass. That is 187.5 imperial. And what is that, 4 millimeters, 4.5 millimeters metric? Grab a piece of material, knock them out. For sake of being able to thin the neck section down on these handles, the plan is to leave one end on where the square broach will go and engage the machine. This is the thinned out section. This will be the ornate handle. And I'm going to leave a square chunk on the opposite end, a little square block on the opposite end, so it'll seat comfortably in a mill vise and allow me to mill this down. This is 187, this is 125 diameter. This is a little bit smaller than this. And if you didn't have an equal support block on the other side, you may be in for some challenges trying to knock this section out. So that is the game plan. Going to cut them off to a very specific length. Do maybe some ornate turning in here to relieve some of the stress at a later time. And when it comes time to actually have this done, I'll clamp back on this little square and part it off the length and file it into shape. Okay, we're back. Too much surface contact, and that is what happens. It is a dangerous thing to do, but I gotta have that nub on the end for the milling operation. Killing me, killing me. And as luck would have it, they do not give you enough material to do what I just did. You do not get to screw these parts up. There is no extra material. So that is a big setback. I'm not okay with that. Not even a little bit. But you know what? I'm going to try it again just because I'm a glutton for punishment. Okay, that is going to be the smaller of the curves in the actual handle once the knob is removed and this is rounded off. The last one you just saw snapped off with 10 thousandths less to go. 10 thousandths. My voice is hard. It's gone from screaming. Killing me. Well, after a short but unwelcome delay making the square stock out of a piece of larger 1/4 inch, let's try that again. Problem was too much surface contact on the radius. I will try to move this tool away from the collet about 15 thousandths when I am close to depth to relieve some of the radial pressure on the tool. Let's see if it works. This piece of material is about 6 inches long, so fingers crossed. Ah, come on. You're killing me. All right. One thing left I can try. I will neck the whole thing down. Bear with me. I refuse to lose. The major diameter of this feature is 125. That's about 3 millimeters. I'm going to undercut the entire diameter in the working zone down to 3 millimeters. And then I'm going to put the radius on. Let's see if that works. Something got to work, right? Kill it. Absolutely kill it. You know, if this happens to you repeatedly, back and forth, the machine is telling you something, the setup, the material, the process, it is communicating. So don't be frustrated. It's like trying to figure out why a baby's crying. He's crying for a reason, just got to figure it out. If it's getting under your skin, don't make it personal. Walk outside, take a breath of air, go get a soda, drink a coffee, have a cigarette. Well, don't have a cigarette, but just chill out for a couple minutes, come back at it. This time we're going to do it with a parting tool. Okay, that's a win. This is the setup that I'll be using to relieve the center out of these particular cranks. But you can see that the edge finder is bigger than the part, and the part is hiding behind the stop. Well, this really poses a problem as is, but it's not really a problem overall. Solution is easy. Temporarily, put a bigger piece of material in there. Edge find off the larger stock, and then put your real piece back in the work area. It'll get you there just the same as if you located off your smaller part. Just make sure the piece that you are using is true and square and everything is cut parallel. If you know the part's good, by all means use it. If not, then make one that is. Utilizing a 50-50 approach, I will remove half the material from this side, half from the other side. I can expect a little warp when I remove the material from the first side, but since I did cut this down from around, it may be stabilized. Let's find out. 50 thousandths thick is the target. .68 per side, 1.5 millimeters per side. With any kind of luck, we have a part with an 050 cross section. That is 1.25 millimeters. Let's take a look. After successfully thinning these down to the required cross section, the next step in line is to chamfer or taper the outside edge. I have to go tangent to the round section of this up to this square cross section on the end up here. So it is a very mild angle. Instead of actually figuring out what the angle is, I need to know how much I have to drop from one end of the run to the other and the length of the run, and that is it. With a couple of pins and a plate, you can establish this angle really quick once you know those two numbers. I'll show you how it's done. Once you know the termination point of the angle and the origin point of the angle, you can find out what that little triangle wedge of material that's coming off looks like. You can calculate the angle from that wedge and then determine where you want your pins using the angle and create your nest. Be careful not to place the pins in this area here, because that area is going to be flipped over, and when it's flipped, it'll no longer be straight, so you can't use it. Putting the additional slave material on the end of these parts is proving to be quite beneficial. Let's move it over to the mill, set the cutters, taper this off. If all goes well, the cut terminates at the major square section on the end and blends true to the handle that you turned in before. And we're just going to flip this over, locating on the square ends and not on the part we just relieved off of there. Cut exactly the same shape on the other side. In order to make this look like a cast handle, I'm going to file all these edges off, Scotch-Brite the whole thing, take all the cutter marks out of it, and round this off just a little bit because that is razor sharp. The directions do say to turn this on the lathe. It does not give you the angle. It says to make a big cone out of it before any of the milling is done. But I'm going about this my way. That's actually just one of many ways you can accomplish this. That is just the way that I chose to approach it. The long one is done exactly the same way. I'm going to do the long one, then clean them up, and we'll take a look at them at that point. After a little bit of hand polishing to suit your personal taste, it is time to bend these things. One is a relatively simple bend, the other one is a little bit more complex. 3 bends on this one, 2 bends on this one. This is the fixture that I will be using to bend these levers. The pins are offset to give me the 90-degree reference to the edge here, so I can visually bend it according to the print. This is strictly a plate to keep it rotated in position, ready to bend. And this is an LE phenolic lever that's going to come down and hit it just in the right spot and force it to go down the edge. Let's heat it up, see what happens. Next step in the process is to broach the square drive feature in the end of this handle so we can mount it to the knee. By sweeping the front and rear jaw, or the front and the rear jaw, and coming up with the same number on each jaw, I can assure that the y-axis is established in the middle of the gap. By sweeping in a circle and getting the same number against the brass part that I want to machine, tells me I'm exactly half the distance of the thickness of the stock off of this face, because if it reads 0, 0, and 0, it is truly in the middle of the part, the radius of the part. So now all I need to do is move over one complete thickness of the gap, which would be radius, and it should put me directly in the center of that knob. The tough part of this is I'm going to remove a lot of material from the center of this, and it could very well collapse if the pressure on the movable jaw is too much. So snug it up and make sure that you get the parallel out of the way before you complete this part. Once you drill it out, broach it out, put it together. After just a little bit more bench work, rounding off some corners, taking off some burrs, this crank is complete. The end was shaped by hand. You cannot put this back in the machine to get that square off the end, so if you're going to take that approach, be ready for a little bit of a challenge at the end. And I could probably polish it up a little bit more if I had to. The hole is extremely close to being true. I eyeballed that little square, and I am quite pleased. Anyway, that's what it takes to make one of these little cranks. Heat this up till it's pink. Once it's pink, it'll bend a whole lot easier than the first one I tried, which was not pink, and it didn't bend. It just went oops. There you go. Hope you enjoyed that. It's an awful lot of work for a small part. Got one more to bend up and broach, and I would be done. Thank you very much for watching. It's Joe Pye at Advanced Innovations in Austin, Texas. I'm out.
You motherfucker! Shit! Shit!
Okay, well, I guess I just learned something here. It is not about the temperature of the brass. It is about if the brass has reached a temperature and become annealed. So this is now a soft blank. Interesting. Now let's heat up a real one and see if I can ruin my day on that.